2 out of the 3 sides of a triangle are given, and what can be a possible value for x if we want x to be the shortest side. So we have 3 numbers, 5, 13, and x. You probably have heard that the fundamental fact in geometry is that between 2 points, the shortest distance is the straight, right? And that also feels natural. But that is the same as to say that any other trip from A to B should be longer. And that is exactly what the triangle inequality states. The triangle inequality states that if you add the length of any 2 sides, that should be greater than the third side. If 3 numbers fail the triangle inequality, then there is no triangle with side lengths of those 3 numbers. Actually, there is something more. If 3 numbers pass the triangle inequality, then there exists a triangle with side lengths exactly those 3 numbers. Actually, there is a unique triangle with those sides. So to put it in algebra, the triangle inequality goes like this. A plus B must be strictly greater than C. A plus C must be greater than B. And B plus C must be greater than A. Basically, we just said that any 2 sides, when we add, should be greater than the length of the third side. So the triangle exists if the numbers pass the triangle inequality. Let's just state all 3 versions of it, right? Any 2 if we add has to be more than the third one. So if we add 5 and 13, that has to be more than x. If we add 5 and x, that has to be more than 13. And if we add 13 and x, that should be bigger than 5. And x is a distance, so we shouldn't accept negative numbers. This is it. We just have to find all real numbers x so that all 3 are true. So let's see what these inequalities state. This says 18 is greater than x, but if you look at it from the point of view of x, this is where the inequality is small, it really says that x has to be less than 18. Indeed, if x is more than 18, like 20, then 5 plus 13 is not going to be long enough. So x has to be less than 18. This has to be true too. If we can solve for x, if we subtract 5 from both sides, that will say x is greater than 8. Indeed, if x is less than 8, then that number, say 7, then that number plus 5, it's not good enough to be greater than 13. So now we know that the number we're looking for has to be between 8 and 18. And the third inequality, as it turns out, is not going to give us much because it's stating that it should be greater than negative 8, which is not only included in the fact that we are looking for a distance, but algebraically too. X has to be greater than plus 8. So that this inequality does not bring anything new to the table. It's already true if these 2 are. So the triangle exists as long as numbers are ranging between 8 and 18. But to be a shortest side, it has to be shorter than this side, the one 5 units. So it has to be less than 5 units, but it has to be greater than 8. So there is no such triangle. Indeed, 5 and something less than 5 would not add up to more than 13. So no such x. Thank you for watching.